today is that this messy looking quotient is the identity function. That is, we're trying to show that f of a, we're talking about natural numbers here, numbers, positive integers. We want to show that f of a is equal to a. And we have to start at 2 since 1 minus 2 factorial doesn't make any sense in the discrete case. So again, we're trying to show this. Trying to show that f of a is equal to a. All right. Now, it's just a lot of algebra. I've shown most of the steps here. It's fairly routine. Right here, notice that a is common to all three terms, so we factor out an a. All right. Now, that's all we did on the first step. Now, notice that the parenthetical piece is just a binomial squared. Okay, it's a binomial squared, which is where you get the a minus 1 quantity squared. Okay. Now let's see. Oh, yes. This statement right here, I factored out an a minus 1 factorial. A minus 1 factorial would be the greatest common factor. Now, you can think of a 1 being in front of this, right? 1 times all of this, which is where this 1 comes from right here. Okay. So that's all we did on the next step is just factor out a minus 1 factorial. It's literally the greatest common factor of the denominator here. Okay. Now, and then what I just said a moment ago, this trinomial is a binomial squared. All right. And then on the very next line, I just tried to color code it rather than explain it too much. This piece right here, the green to the green, it's just the definition of factorial. A minus 1 factorial is a bigger number than a minus 2 factorial. All right, but a minus 2 factorial times a minus 1 is just a minus 1 factorial. Okay, so hopefully the color coding helped a little bit right there. Now also notice what we get here. You can see already everything is going to cancel out nicely. This would be equal to, I'll just recopy the numerator, a times a minus 1 quantity squared. Okay, times a minus 2 factorial, the quantity. You know, I could basically just say, can you see it? But we'll just be explicit here. Now, and then downstairs, what happens that's very favorable is that we have 2 copies of a minus 1 juxtaposed, right? And so you see that means we're going to have a minus 1 quantity squared again, which is a nice thing in terms of cancellation. So we have a minus 1 quantity squared. And again, that's just this a minus 1 that fell out from this factorization and this a minus 1. Then, of course, we still have a minus 2 factorial. All right, and so clearly everything in sight cancels. These two guys cancel, and then these two squares cancel, and so we get equals to a, which is what we set out to do, if you recall. We wanted to show that f of a is equal to a, so we've shown that this entire expression is nothing more than an ostentatious version of the identity function. Now let's just work a concrete example. Okay, so we've shown that this is the case. Do I have room up here? Let's try it out for maybe, let's try it out for maybe f at 4. Let's see, f at 4. Let's come back up here, folks. So let's get some space here. Okay, so we have shown this. Okay, we have shown this. So let's just do a calculation so I can keep everything on the same screen. F at 4. F evaluated at 4. Okay, folks, now I'll do some of these computations. I won't bore you with all the details, but F at 4, okay, is equal to, all right, now, so 4 cubed is 64, this is 32, so you would have 36. And y'all, again, I'm being cautious with the calculations here. So this part right here would evaluate to 36. Now, if you put 4 right here, you get 2 factorial, which is 2. So you have 36 times 2, right? 36 times 2. Again, folks, 4 cubed is 64. 2 times 4 squared is 32. 64 minus 32 is 32. Plus 4 is 36. But then 2 factorial is 2. So you get 36 times 2 in the numerator. Now let's check out the denominator and see how that works out. So 4 factorial right here, this 4 factorial would be 24. Okay, 1 times 2 times 3 times 4 is 24. Okay, minus 3 factorial was what you get right here, right? 3 factorial, but 3 factorial is what, 6? Okay, ladies and gentlemen, this looks like it works out pretty nicely. You see, we end up with 72 divided by 18. And guess what that's equal to? That's equal to 4. 4 times 18 is 72. Okay, so we get 4 like that, all right? And so, wow, it worked for one special case. So it checks for the one special case, but we have no doubt that it's always true. F at A is equal to A, and all the work here hopefully was clear. Hope you enjoyed that. I thought it was pretty cool.